So we looked at classical probability. Now what is empirical probability? Empirical means experiment, is to actually do experiment. So if I roll a dice and I get 5 and I say, okay, I'm going to write all these numbers down. I got 5. Then I roll a dice again. Then I get another 5. And I roll the dice again. Like this I keep rolling dice for the trials, and I have hundreds of trials, and then from that I try to estimate what is, when I roll it next time, what may I get. Okay, so here you are not really using the classical probability, but you are using experience, and you are doing a lot of measurement and saying based on the measurement, based on empirical evidence, which means based on measurement I have done over time, this is what I think, right? So this is called empirical probability. And here you could also address things that we didn't address before. For example, we talked about what will be the temperature tomorrow, right? So I've been measuring the temperature the last 10 days, and I say, it's not going to change that much. Most likely the temperature is going to be similar to what I have got so far. So, or I take over the years and say, okay, over the last, I saw the temperature, I have the temperature graphs from the last 5 years, and they look like that. It's similar, somewhat, maybe a little bit off, sometimes a little bit here and there. And I use all that and say, based on all that data, I am going to say, this day in this year, like today, this is the entire year, 365 days, right? So that's 365, this is the first day, 1st of Jan. So I have these graphs, and I'm trying to figure out from that, I'm trying to make a guess of what today's temperature is going to be. So this could be empirical, which means based off measurement. Subjective is that I just feel like it. So I feel it's going to rain tomorrow. Now this may not be the same feeling other people have, so it is based on the subject, based on the person. So that's subjective. And axiomatic is basically working on, let's say the entire set theory that we were talking about just now in part 1, in which you have one set, another set, what is a union, what is the intersection, and based off it extending the idea of guess, this probability, the chance, based on these axioms. Or based on these, they are not theorems because they are not proved, they are axioms which generally appear to be true. So if you look at empirical probability, so I have this one out of only one red, and I have 5 green, and so if I mix up the bag and I shake it around and then I randomly pick out one, what will I get? And then I say, okay, I get green. So the next time I mix it up, and then I pick out one more. So what do I get? I still get it. And I again mix it up, and then I pick out one more. So I basically see that, okay, I had 5 and 1. Classical probability says that if I didn't keep it nicely in one place and I pick it out from there, then only 1 out of 6 times on an average, 1 out of 6 is a chance that I will get a red. So there is a central limit theorem which basically talks about empirical, if the events are truly, if each of these events are truly independent, then over time the average that I get as through empirical data should be the same as what I get through classical probability in a case like this. If it was perfectly fair, then the two tend to become equal over time. So that's called the central limit theorem, and you can do it in a class, right? You can take something, if it's perfectly fair, and then you just keep listing and seeing if you really get 1 out of 6 times on an average, if you have enough possibilities, not if you have a small number. It doesn't work with small number. So that's called the central limit theorem. So in a limit, with your possibilities number of empirical tending to infinity, the two will come close together. That's the idea.